We are continuing with the topic partial differentiation, and in this lesson we are looking at the second objective, that is differentiating a function of more than one variable. So we start off with an example. We are given a function z which depends on x and y. Z is equal to 4x squared plus 3xy plus 5y squared. We have divided that into 4 parts so that we have 4 elements that we're going to look at in this lesson. The first one is to get partial derivative of z with respect to x. The next one is going to get partial derivative of z with respect to y. Then we're going to get the second derivative of z, first with x, then second with y. They also get partial derivative of z, second partial derivative, first with respect to y, then with respect to x. So let us look at how to deal with it. Because we have z as a function of x and y, we get part A. Solution is partial derivative of z with respect to x, which is equal to partial derivative with respect to x of z. We substitute 4x squared plus 3xy plus 5y squared. Then we are going to partially differentiate each of the terms so that we have partial derivative with respect to x of the first term is 4x squared plus partial derivative with respect to x of the second term 3xy plus partial derivative with respect to x of 5y squared. Because 4 is a constant, we can put it outside. Partial derivative with respect to x of x squared plus, because we are doing partial derivative with respect to x, 3 and y are treated as constants, so we have 3y partial derivative with respect to x of x plus, this one is now a constant, 5y squared is a constant because there is no x in it, so that gives us 0. If you differentiate a constant, you get 0. Now proceeding, we get 4 times. Now we drop the 2 down there, then we have x2, we reduce it by 1, plus 3y times x raised to 1, we reduce by 1, we add 0. And this gives us 4 times 8, 4 times 2 is 8, we have x raised to 1, plus 3y times x raised to 0, plus 0. And this gives us 8x plus 3y. That is partial derivative of z with respect to x. We can also work out partial derivative of z with respect to y. So we have part B. Partial derivative of z with respect to y is equal to partial derivative with respect to y of z, which is 4x squared plus 3xy plus 5y squared. In this case, we are treating x as a constant, so we have partial derivative with respect to y of the first term 4x squared plus partial derivative with respect to y of 3xy, that's the second term, plus partial derivative with respect to y of the third term, which is 5y squared. Now, because there is no y here, 4x squared is a constant, and when you differentiate a constant to get 0, then we have 3 is a constant, x is also a constant, 3x partial derivative with respect to y of y, plus 5 is a constant, partial derivative with respect to y of y squared. So this gives us 0 plus 3x times y raised to 1, reduce it by 1, we add 5 times 2, bring the 2 down, y raised to 2, reduce it by 1. And this gives us 0 plus 3x times y raised to 0 plus 10 y raised to 1. Simplify that, we get 3x, y raised to 0 is 1, plus 10y. That is partial derivative of z with respect to y. Now we do second derivative, first with x, then with y. This is how we do it. So for part C, we have partial derivative with respect to y and x. So we start by doing partial derivative with respect to x. So we have partial derivative with respect to y of partial derivative of z with respect to x. When you're given a case like this one, the one that is on the right is the one that we start with. So we are differentiating the second time after first time with respect to x. So this gives us, if you substitute to get partial derivative with respect to y, we have done partial derivative with respect to x and we obtained 8x plus 3y. So this is going to be partial derivative with respect to y of 8x plus partial derivative with respect to y of 3y. Because the first term doesn't have y, it's treated as a constant, so this gives us 0 plus 3 is a constant, partial derivative with respect to y of y, this gives us 0 plus 3 times y raised to 1 reduced by 1, and this gives us 0 plus 3 y raised to 0, which is equal to 3. That is second derivative of z, first with x, then with y. Then we have partial derivative of z with respect to y and with respect to x is equal to 3. We can put this one aside. There is something that is important about it that we will discuss. Then we have part D. We do it in the same way. We are doing second derivative of z with respect to x after doing with respect to y. This means we take partial derivative with respect to x of partial derivative with respect to y. So this is partial derivative with respect to x. We have done partial derivative of z with respect to y. That is 3x plus 10y. Now, we are going to have partial derivative with respect to x of 3x plus partial derivative with respect to x of 10y. This gives us 3 is a constant, partial derivative with respect to x of x plus, because there is no x here, the second term gives us 0, and this is 3 times x raised to 1 minus 1 plus 0, which is equal to 3 times x raised to 0 plus 0, which is equal to 3. That is second partial derivative of z with respect to x and with respect to y. You can also put this one aside because we might need it for that explanation. That's how we do differentiation of a function of more than one variable using partial derivatives. So the first one, we are doing partial derivative of z with respect to x. In this case, y is treated as a constant. That's why we obtained a 0 here. Then for the second one, we are partially differentiating z with respect to y. And in that case, we have held x constant. That's why we have obtained a 0 here. When you do that, you get these two solutions. The first one is partial derivative of z with respect to x. Then the second one is partial derivative of z with respect to y. And the third one is partial derivative, second partial derivative of z, first with respect to x, then with respect to y, and second partial derivative of z, first with respect to y, then with respect to x. There's something that we need to notice here. Second partial derivative of z, first with x, then with y, is the same as second derivative, partial derivative of z, first with respect to y, then with respect to x. And we can write that one somewhere at the center here, that partial derivative of z, first with respect, the one that is on the right is the one that we start with, first with respect to x, then with respect to y, is the same as second partial derivative of z, first with respect to y, then with respect to x. That is a very important point from this lesson. Very important. That's our second objective, and I think we have completed it. In the next lesson, we will look at the third objective, that is partial differentiation and obtaining small changes using these methods. Let's meet in that lesson.